Today, welcome back to Statistics. I would like to go over the last chapter that you'll be responsible for here at Hudson Valley, and that's Chapter 13, Regression Analysis. Regression analysis is completely different from all the other chapters, and I don't know if I mentioned this in the earlier videos, but that's one thing nice about statistics. Once you're completed with the chi-square or the any of the other tables, it really doesn't carry over. Once we were done with probability in Chapter 5, we were done with it until the final. Same thing here. This chapter is the first time we're going to talk about two variables. Okay? Up until this point, we were talking about one variable. Maybe the number of desks we produced, the number of baseball cards we sold, maybe the number of fuses that somebody produced. Okay? Today, we're going to talk about two variables. Maybe the amount of hours you study and your grade. Two variables. Maybe the size of your house versus the cost to heat your house. Two variables. What's very important in this chapter is you pull out your calculator, whether it's the TI-30 or one of the TI-83s, 84s, or 85s. It's imperative that you learn how to use it. All your calculations will be on the calculator. Even my PowerPoint presentations that you can review show other formulas. I don't want you to use them. I want you to use your calculator. If you go into the reference section of Blackboard, there is a handout on how to use your calculator for linear regression. Please print that out. I also have how to use your calculator on the handout for this chapter because it's so important. I do not want you to calculate any of these variables by hand. We're going to calculate R squared, A, B. All of those need to be done by your calculator. I hope I emphasize that enough. I'll probably scream at you a couple more times throughout this chapter that it's very important that you use your calculator. So if you don't have a handout and you don't have your calculator and something to write with, pause the video and come back to me. Okay. Ooh. Here we go. Linear regression, Chapter 13. Always calculate R squared, A, and B with calculator, not the formulas. I do show those to you so you understand where these numbers come from. The other critical point here, especially with the TI-30s, A and B may be reversed on your calculator, depending how your calculator was set. So as we go through problems, you are going to have to determine whether A is the slope and B is the y-intercept, or A is the y-intercept and B is the slope. You are welcome to write this on your formula sheet. In other words, for the linear regression equation, you can AX plus B or BX plus A. I don't know how your calculator operates. On the graphing calculators, you can choose. There's an option 4 or option 8 on the graphing calculators. On the TI-30s, you are going to have to determine how your calculator, whether your calculator has A as the slope or B as the slope. Don't know. I'm not there sitting with you. These instructions for the TI-30 will tell you how to calculate A, B, and R. On the TI-30, you can calculate R, A, and B. We'll print out. You are going to have to square R in order to get R squared. You don't get R squared on this calculator. Okay? On the TI-83, 84, if you turn your diagnostic on, which is the first step, you will get R, R squared, A, and B. So for $100 more, you get R squared calculated for you. Okay? So I strongly recommend you pause the video, go over these instructions for your specific calculator, and a couple of things. I want you always to clear all your data. Okay. I always want you to clear your data. I want you to set your data to accept 2 variable data for the first time. And if you have one of the TI 83, 84, 85, you must turn on your diagnostic. So every problem you have to prepare your calculator. I've had students say, oh, they didn't clear it and therefore they got results, or it switched their A's and B's in the middle of it. So please, it's imperative that you clear your calculator and prepare it for accepting data. So the first problem, I'll go back to the DocCam. The first problem we're going to discuss is the number of sales calls and the number of copiers sold. So I want you to pause the video, and I want you to practice putting in these data points. This will be in TI 30. This will be your X1, Y1, X2, Y2. In your graphing calculators, this is L1 and L2. So do that. After you've put in the data, I hope you've practiced, you will find the slope. You want to find the slope of the line. In this case, it's 1.1842. Your y-intercept is 18.9476. When I ask you what is the equation of the line, I might say, what is the linear equation? I might say the sum of the squares. Those all mean the same thing. I want you to write y-intercept plus slope times x. This is the equation of the line based on this data. I hope you saw it. This is the equation of the line based on this data. Do not, on a test or a final, write, oh, this is the equation of a line. No. That is a general equation, but it's not the sum of the squares equation of the line for this data. This is probably one of the most powerful things you will be taught this semester. It's used commonly in the business industry. Now here we're looking at the number of sales calls versus the copiers sold. One of the first steps you want to do is you want to write a scattered plot. This would be sales calls versus number of copiers. And if I do my 10 data points, I have a line here from my 10 data points. I'll make them a little darker here so you can see them. This line is y equals 18.9, I'm going to round it off here, plus 1.18x. That's the equation of the line. Okay? Now, we found out that B, the slope, is 1.18. And A, the y-intercept, is 18.9. What do these mean? Let's look at the y-intercept, 18. It means if we do 0 sales calls, we get a value of 18.9. In other words, y equals 18.9 plus 1.18 times 0. when I say 0 sales calls, X equals 0, and I substitute it in here, Y equals 18.9. We will still sell about 18.9 copiers if I make 0 sales calls. That's an important piece of information for a business to know. B, the interpretation of B is for every 1 sales calls, let's say if I go from 10 to 11 sales calls, I will sell 1.18 copiers. Run over rise, the slope. You know, when you did it in high school, you just found y-intercept and slope. Now in the business world, they have meaning. It means for every sales call every 1 more sales call I instruct my salesmen to make, I should expect to sell over 1 more copier. So let's look at another piece of information. Let's say we're in business and we say, oh, okay, this month I want every one of my representatives to make 20 sales calls. Well, in that case, in my equation, I am going to substitute 20 in for X, and I get 42.63. I can expect, on average, that every salesman will sell 42.63 copiers. I put 20 into my equation here, and I got 42. In other words, here's 20 sales calls. I come up to my line, and this would be 42.6. I would expect 42.6 copiers to be sold. Okay? That is the majority of what this chapter is about. I'll quickly do one more example that you have on your handout, and we're talking about advertising, how much money we spend on advertising, and is there a relationship to sales revenue. The other thing I want to point out, it's very important you understand dependent versus independent. Dependent is the y-axis, independent's the x. The x is the predictor. It predicts how many, in this case, how many sales. Okay? Advertising is the x, or the independent. Sales is the y, the dependent variable. Scatter diagram. Okay, I'll do a scatter diagram here. 1, 2, 3, 4. And 10, and 5, so 2 to 7. I do this to get an idea of my data. 1 and 3, 3 and 8, and 4 and 10. So you can see this data. Oops, sorry about that again. If the data is in this direction, it's positive. Okay? If it is in this direction, for example, size of an engine and miles per gallon, this is negative. There was, on the last example, there were 2 important variables that I forgot to calculate is R and R squared, and I'm going to do it on this example because you will be tested on those 2 variables. Not only A and B in the linear regression equation and learning how to substitute into it, but you have to understand R and its value. Now, if we talk about R, we'll go through each of these. We want to determine the coefficient or correlation. That is R. So I want you to spend a couple of minutes, empty out your calculator. I want you to put the X variable in, the Y variable, and I want you to calculate R square, A, and B. Okay, so you've come back. I hope you did that. R is 0.96. R square is 96 squared, or 93. Okay, what does my R tell me? If it is near 1 or -1, it means a strong correlation. It means these data points are very close to the line, and you have a good estimate between the amount spent on advertising and sales in this case. Okay? There's a strong relationship. If this number is negative, it means it's in the negative direction, and if it's close to -1, it means the data points once again are close to the line. I'm going to show you an example. If this is R, -1 and 1. So we said it's strong and positive, strong and weak. If it's near 0, for example, we'll say an R of 0.20 right here. It's a positive relationship, but the data points aren't too close to 1, and it's not strong. It's a little iffy if it's a good predictor. If R, let's say R is about -0.6. So it has a negative relationship, and the data points are somewhat close. So it's negative and a moderate relationship. R gives you two pieces of information, whether it's positive or negative, and whether it's strong or weak. Strong or weak. So in my example of advertising versus revenue, 0.96 is very, very strong. Very strong. Very unusual strong. So here's my plot. When I calculate R squared, I got 0.93. This is usually represented by a percent, like 93%. And what does that mean? It means 93% of my sales is attributed to how much I spent on advertising. So if I had a couple of extra dollars in my company, I would put it in advertising. I wouldn't put it into training employees. I wouldn't put it into maybe hiring new employees, believe it or not, because so much of my sales is attributed to advertising. Very typical of car sales, by the way. Advertising has a very strong relationship to the number of cars sold. So I hope that gives you an explanation of R and R squared, or the coefficient of correlation, the coefficient of determination. Now, we're going to determine the regression line, or the regression equation, or the sum of the squares, all of those. Well, I found A on my calculator was 1.5, and B was 2.2. So the equation for the line, which I'm going to come down here and make it nice and big because it's important, is y equals 1.5 plus 2.2x. What does A and B mean? Well, A is the y-intercept. It means if I spend 0 on advertising, I can still expect 1.5 million in sales. In other words, I substitute 0 in for X, and I get Y is 1.5 in sales. Okay? What does B represent? It means for every $1 spent in advertising, I should expect 2.2 more in sales. Say if this is $1 million. For every $1 million in sales, I should expect 2.2 more million in sales. Okay. Now, number 7, that's the power of regression. Estimate sales with 3 million when 3 million is spent on advertising. So in my linear regression equation, I'm going to put y is 1.5 plus 2.2. This year I have 3 million to spend on advertising. If I do that calculation with my calculator, I will get 8.1 million in sales. So I can predict how much sales I'll have. I think this was a furniture example. So therefore I can talk to my suppliers and tell them I'm expecting 8.1 million in sales. I can talk to my service people and say, you know what, I hope you can handle 8.1 million in sales because that's how much from my regression equation I am expecting. And you better staff that way. So there's a lot of good information with regression analysis. It's used every day in the business world. I don't know if I told you that my first career was an engineer here, and I designed brakes for cars. And my market, or where I designed cars, was for Toyota and Hyundai. Okay, and the brake pads, we would add more, maybe the cars would come over here and they didn't meet federal requirements for stopping distance. So we would say, well, what happens if we add 2 more grams of steel in them? How will we stop? How will that affect? How about 4 more grams of steel or 6 more? And we could create a linear regression equation to estimate stopping distance. We could do the same thing with rubber. Rubber is one of the raw materials in pads, and we could estimate if we add rubber. Actually, rubber does stop a car, and it also reduces noise. So with regression analysis, we would look at the noise, adding the rubber and its effect on noise, or adding steel and its effect on stopping distance. 2 variables, and we would calculate a regression line with that information. So I think I gave you about 80% of Chapter 13. You need to understand R, R squared, the A, B, how to make the linear regression equation, how to estimate with the linear regression equation. And that will wrap it up. That wraps up the semester. I hope these videos have helped you. Previous students have really felt that this was a little better explanation than just my PowerPoints. But once again, if you're a little bit confused, shoot me an email, stop by my office hour. I'm always willing to help you. If it's not convenient, maybe we can work on unconventional office hour. I do teach some night classes, some semesters, and I might be able to help you. Thank you very much for taking my online or my hybrid class. I think it is a great option to students that can't make it to campus 4 times a week. Good luck.